exponential function. F of x equals a power of x, where a here is greater than 0 and a should not be equal to 1. Again, a should be greater than 0 and a not equal to 1. So what happens if a is equal to 1? That will give you a horizontal line, not an exponential curve. If you have a is equal to 0, that's undefined. For the values going to the left of the x-axis, going to the right, it gives you a horizontal line for positive values for x. Okay, so we will actually try to show that to you in a few minutes. So we will use our graphing calculator here to show you the graph first, and then we will do it by hand. So here's the graph here. The f of x is equal to 2 power of x. So you have the red curve here, and as you can see, that's the exponential function. And if I'm going to take a horizontal line test, y is equal to 2, for example, you have only one intersection here, so it means this is a one-to-one function. So if this is a one-to-one function from the previous presentation, this curve has an inverse. So the inverse of this, it's the blue curve here. And as you can see, that's exactly the reflection of the red curve. And that is the log function. So that's the second one that we put here. Y is equal to log with base 2 of x. Okay. And if you're going to test also using a vertical line test, x is equal to 3, for example. So you can see that you have only one intersection. So it means that's a function. Okay. So those are the horizontal line test and the vertical line test. So now analyzing these two curves, we say that the second one here is the inverse of the first one, which is the exponential. So exponential function, the inverse would be a log function. So the reflection line is y is equal to x, and that's the black slanted line here. And as you can see here, the definition that we had before for inverse, looking at an intercept here, which is the y-intercept, and then we have the x-intercept here. So the values are just interchanged. So you have 0, 1 here, and we interchange the x and the y values, then you have 1, 0 here. So it means that the blue curve is exactly the reflection of the red curve here. So the reflection line again is y is equal to x. You can also say that is the line of symmetry. Okay, so and playing around with the exponential function, if you have a negative exponent, this one will flip also. So it's like reflected on y-axis. So you can see a while ago it's increasing, now this one is decreasing for the entire domain. Okay, so you can see the previous one with positive, it's like a hockey stick and it's increasing. And analyzing this also, we have a horizontal asymptote here at the x-axis, which is y is equal to 0. I'll just use a different color here. So let's have the blue one. And analyzing the graph here, it's the red curve approaching the blue line, which is the x-axis, y is equal to 0. So that is our asymptote there. So the red curve is not touching the blue line or the x-axis, it's just approaching to that line. So you can see also that the domain here is all real numbers by looking at the graph. So it's parenthesis negative infinity, comma infinity, parenthesis for the domain. The range would be parenthesis 0, comma infinity, parenthesis, since the curve is not touching the x-axis. Now, if you're going to trace from left to right, it's increasing throughout the domain. So from left to right, there's no decreasing part of the curve. There's no constant. There's no horizontal line. So it means there's no constant. And it's continuous. There's no broken part of the graph here. Okay, so you can always go to this graphing calculator and analyze your graph. So this is really handy and easy for you to understand the different functions. Okay. Now, a while ago, we said that a cannot be equal to 0, and it should be greater than 0. Okay, so if you have a 0 here, as you can see, the left side of the graph is just a line that's going to be created. It's a horizontal line, but going to the left, there's no line here. That's the red line, since you will get undefined there. When your a is 1, it's just a horizontal line passing through 1. So it's not an exponential curve. So but if you play around with 2, you have an exponential curve. 3, that is still the same shape. 4, 5, 6, and so on. Okay, so we will actually do this graph by hand. Okay, so we're going back to our whiteboard. Okay, now let's take an example with that one. And that's f of x is equal to 2 power of x. And this is an exponential function. And we're going to assign value for x and solve for y. Okay, so let's assign -2 here for x. So if x is -2, remember this can be written as y is equal to 2 power of x. So therefore you will get 2 power of -2. Then you cannot have a power of a negative. You have to bring that down to the denominator side. So you'll get 1 over 2 power of +2 now, because when you move, your exponent will become the opposite sign. So you have a negative, it becomes a positive here. So the answer would be 1/4. So we have 1/4 here for y, and then -1 for x. So that would be 1/2, because 2 power of -1 there. And bring that down, it gives you 1 over 2 or 1/2. And then 0, 2 power of 0, that would be a 1. Okay. And then next value for x, we will have a positive 1. So positive 1 for x, it gives you a 2. So that's 2 power of 1. So the answer would be 2. And then if x is 2, 2 power of 2, that would be a 4, right? So you will have y is equal to 2 power of 2. You will get a 4. So 4 goes to your y here. And then you can make the graph now. So this is our y axis. And we have our x axis here. And we're going to plot the points now. So here's our first point here, first ordered pair, -2, 1/4. So we will have 1, 2 for x here, and then -1. Going to the left are negative values for your x. And then for y, the maximum is 4 there, so I'll just have 1, 2, 3, 4. So we have 4 there. Okay, going down would be negative values for y. So let's have that -2, 1/4. So that should be somewhere here, -2, 1/4. And then the next ordered pair is -1, 1/2. So that's a little bit up with the first point. So -1, 1/2, and then we have the y-intercept. So we don't have x-intercept here because the curve is just approaching the x-axis, but we do have the y-intercept. That's 0, 1, so that should be here. And then 1, 2, 1 for x and 2 for y. So that should be somewhere here. And then 2, 4. 2, 4, so that should be somewhere here. Okay. And then just draw a smooth curve along those points. Okay. So analyzing the whole graph here, we call this a continuous graph. There's no broken part of the graph here. Now, is it increasing, decreasing, and constant? Now, we trace the graph here from left to right. It's all the way up, so it means it's increasing for the entire domain. So our answer for that question would be increasing. On what interval? Remember, the smallest that we can have for x here is -infinity, and the highest for x here going to the right would be +infinity. Similarly to your y-axis, the highest going up would be +infinity, and going down would be -infinity. So increasing, you look at the domain for increasing, decreasing, and constant. That would be -infinity going to infinity. Now, do we have decreasing part of this? No, we don't have it because that's all the way increasing. So none for the decreasing part. Constant, there's no horizontal line, so it means we don't have one also. So that's none. Then for the domain, it occupies all the x values. So domain here would be same as the increasing, it's all real numbers. Range would be the y. And remember, the graph is occupying only the first quadrant and the second quadrant. It never touches the x-axis, and it's not crossing the x-axis also. So it means you will get parenthesis 0 here. So it means it's just approaching to 0. The graph is not touching 0. And then comma positive infinity because it's going up. So that would be the range. Okay, so those are the things that we know for um, this function. Exponential function f of x is equal to 2 power of x.